Hello friends, a very good morning to all of you. We are here to discuss the DBMS course. DBMS is Database Management Systems. This is the core platform, core programming tool for core programming strategy for building all the different tables, especially in the large data sets, large companies. So this course is completely designed to discuss the basic principles to so that we can move forward onto the designing the new database. All right. So my name is Ashish Shuntla. I am working as associate professor in the Department of Basic Sciences within the School of Science and Humanities in SR University, Warangal, India. This course all includes the SQL fundamentals, like entity relationship. We'll be discussing how the entities are defined, and then how the attributes are clubbed to different entities, how the relational database is designed based on these entities and attributes, how do you study the complete objective, how do you design what are the keywords which are building the entities, and what are the keywords which are important characteristic features to define the attributes of these entities. Okay, and are there any duplicate entries, or should we include the correlation part between different tables? We'll be discussing all these aspects further after. Whenever we are designing the database, we have to call several tables. So we need to use the set operations, wherein we call multiple tables together to draw our desired results. Okay, so the SQL performs all the tasks necessary to give you the required result rather than we using the filter. Like in the Linux part, you might have seen a grep command is there, or like C or C language also different commands are there for comparing strings and other things or comparing files. But here SQL do everything for you. Okay, just by a single keystroke. Further, after the dependencies which define the integrity of different data sets. Okay, and the extraneous attributes means which are the additional attributes whose presence or absence do not affect the results significantly at all. Okay, further after we need to organize the file records and optimization of search time. Okay, that how the file records are defined in the database, how they are stored. Objective is to retrieve them as early as possible. Okay, so SQL does not wait for too long for the processing the database, or processing the keystrokes, or processing the command. Okay, even if you give a big script, SQL hardly takes a few seconds to give you the results, even if the database contains millions of records. That is the strong robustness and the processing speed of the SQL. How it is programmed, how it is storing the table, how it is able to retrieve different data from different tables to give you the desired results. Or if it's calling multiple tables, of course the integrity constraints are there. Okay, so some keys are part of within the core keys of certain tables, and like your user id becomes the core key for your table. Okay, and some keys are additional keys, okay, or the foreign keys, but we have to always maintain the integrity. Further, after the indexing methods and the database security, all these parts maintain the complete database design as such. So we'll be discussing all these concepts right from scratch. Further after, please note that even if you are new to the system, even if you are new to the course, you don't know even the basic ABCD of this DBMS, this course will make you substantially much ahead of the class. Okay, so you will be at the 60 to 70% DBMS part, but you need to just keep on learning the things, and keep on practicing the aspects, all the concepts, all the programming parts, all the different scripts which are provided here. you need to practice them at home. Okay, then you will be like 60 to 70% through of the all the core concepts. Okay, I'll be making a DBMS advanced course after this part. Okay, so that will make you 95%. All right, so let us start this part further. All right, so let's discuss the DBMS further. See, the DBMS or the database management systems consist of all the files which are termed as flat files. Okay, these files are nothing but tables. Only the data is stored. But SQL is given as an additional tool just to like as an interface to retrieve the data from different tables. Okay, just like you are opening your Gmail account or Facebook or Instagram account. Okay, all those tables, all those things, all those user IDs are present somewhere. The moment you open the account, it is retrieved, like certain part is retrieved. So it takes some time to spool the data, like depending on your user ID. So it searches the required files and then give you the required results in the form of tables. Okay, so all the output there is just a table. Like even if it's having image, movies, MP3, any kind of data. Okay, so it's a complex data, but yes, so complex tables can also be there, and we'll be discussing more on that later. Okay, so all these are nothing but simply the files which are there and the tables. So DBMS is a set of programs to access the data. Okay, and it's used at large scale, not only in like small schools or big colleges or big universities. Everywhere, DBMS is used, right from ticket booking somewhere to like a flight booking or anywhere. See the part I've just given broadly. Scientific, every big analytic resource or repository database, okay, which consists of billions and trillions of files. Now you can imagine how much complicated it is there. Banking, all the banking transactions, airlines, the reservations or the schedules, the universities, the registrations or the grades. Okay, there are different students coming up in different year. They are just added as new files within the same system, rather than changing the entire system as such. Okay, they don't design a new system, they just add a new file for the new students within the old part, nothing else. Okay, the manufacturing aspects, the production, inventory, order, supply chain, and all of it. Human resources, the employee records, the salaries, tax deductions, and all of it. All these parts are including everywhere, are just touching our lives at multiple places. Alright. So what are the major purposes of database systems? See, the database systems are built on top of file systems just to store the data properly and get it retrieved whenever it needed, so that we need not waste too much time in searching or like getting the required results. Okay, like long back or primarily we have been using the file systems or the search command in Windows or somewhere. But what happens? There are multiple file formats. Okay, we have to change the commands every time based on the extensions. Okay, difficulty in accessing the data. How do you work it out? Some file is there somewhere else. I need to get it mailed or provided it in soft copies. Okay, the data redundancy there in different parts. Okay, how do you work it out? So we every time need to get the new data, but so data duplications, then integrity problems. Okay, many times you have seen like my like some account number in the bank has gone like negative balance, and the bank manager immediately get to know that this part is having low balance or negative balance, so you need to pay the penalty. The system keep on sending the messages rather than proper person sending you the emails, system keep on doing it by retrieving it from the tables automatically. So it just saves too much time and energy for different companies to work out so many things for so many people. Okay, like Swiss Bank or some other SBI bank in India or some other bank. Okay, they deploy these for the billions of customers. Okay, but managing everything within just keywords, few commands, they get it all. And see, so simple it is. With every new year, they are able to add interest. The system keep on updating itself rather than persons changing the files. We don't edit anything. The system take care. Okay. All right. So I'm sorry. After discussing all these important applications and the advantages, like let us discuss it further. Okay. When I am using my file part on different computers, I need to work it out differently. The tool software may not be there, or the software definition or the versions keep on changing the things. Like Windows, you might have seen the MS Word .doc came, then .docx came. Even if the file is there, I am unable to open it, it is worthless for me. But in the case of files or especially the tables in SQL, all are same. All are tables, all are same. No difference at all. Even if it's a big complicated file or simple file. No extensions, nothing, only the file name is there. Okay, that's the simplest advantage. And concurrent access by multiple users. We can give the specific permissions to different users to see only their part. Like I am able to see my Gmail account, not my wife or son's Gmail account. See, even if I should have the authority as a family member, I'm not authorized to do it. So see, so much security is there. Likewise, my bank transactions, they are completely hidden from my father. Okay, my father is unable to access it. Okay, these are so much part. So example C, two people reading a balance and updating it on the same time. So like my withdrawn some money from my bank. Okay, my bank is having 2000 rupees. I withdrawn 200 rupees, so it should have 1800. At the same time, my wife purchased something else somewhere from for 300 rupees. System take care. Okay, system even if it shows the wrong balance later on, wrong account balance, it updates automatically. Okay, so that nobody is at loss. Okay, so these are numerous advantages plus security problems. Okay, like no need of antivirus solutions and other things for MySQL. The tables and other things automatically manages it. Though the viruses come to destroy the tables, but yes, the SQL has a secure way of doing it. Now let us discuss it further. Now understand that when the database is designed, we call it DDL, database definition language. Here the main objective is to design the table or the schema. We call it schema here, schematic. Okay, we design the schematic or the schema like how every table will be there. Just see for an example, I'm using a create table command. Yes, by the way, like with the different presentations, I'll be introducing different commands. Okay, so all these sessions go in a flow. So please keep on building a record of like different commands. Okay, so that you can build your own like conceptual backup. Okay, like that you'll be able to learn or grasp it better. Okay, don't forget the earlier commands. Keep on practicing them at your place. So create table and then this is a command specific keywords which I cannot change. So I've kept them bold. Likewise here. Okay. Then I'm putting an account. Account is the specific table name. Create table and then the table name. I'm opening a bracket parenthesis, account number and balance. I'm declaring two more strings here. The first string account denotes for the account table name. Further after, when I'm opening the bracket and then I'm putting the part like it has account number character 10 and balance integer. Okay, so this main bracket closed here. Character 10 I am putting because it is itself a string. So account number can be of 10 characters. Okay, nothing more than that. So account number and balance I declared. Account number is a string. See, the character part is there of 10, a string of length 10 characters. Further after the balance, the integer. Okay, so the whole number will be considered here, the integer aspect. Okay, not decimals. This DDL defines the table. So here with this like particular script, I defined a created a table account with two important attributes. I'm see that term. I'm using the word attribute here, or the specific characteristic part, which is a part of attribute for that table account. Okay, so every table account will have the account number of length 10 characters and the balance of the integer type. Okay, this way all the tables will be stored, but now I am only declaring what is the format of all the tables. I am not at all storing the data in there. Okay, take care. So these kind of things are normally used by all the administrators which are building the tables, okay, creating the integrity among different tables and working it out. Okay, so like that they are stored, like stored in different tables, stored at different tables in the data dictionary. Okay, so data dictionary is just having a data about my data. Okay, the main data will be stored later when the users read and update the tables, but this is just the data about the further oncoming data. So we call it metadata. Metadata, data about data. Okay, so which DTL is able to create it. Got it? Let us discuss it further. Hereafter comes the DML, that was Data Definition Language, DDL, which forms an important chassis of the complete DBMS part, how the data will be stored. Further after, what comes here is DML, how do you store the data, how do you edit the data, how do you work it out, okay, or how do you call the data from there. Data manipulation language, okay, editing, storing, all those aspects. Okay, so you're basically calling the values and then editing or changing the values if needed. So here is called as DML. This is of two types. Okay, either the procedural or non-procedural. Procedural means where the data is there, whatever the thing is there, I'm properly specifying. Okay, what data is needed and how to retrieve the data. I'm properly telling. Just like the file path, file thing, everything I'm telling. And that is a procedural. We'll be discussing the details later. Non-procedural means when I'm not at all telling anything. I just say I want this without telling what is the like a location of this file, the location of this particular data, nothing. Because as a user I also don't know. Okay, so like you're opening your Gmail account or any account, you don't have what the information with what file name your information is stored in Gmail server, nothing. But still you are able to open it only through your user ID. So this is a category of type of non-procedural calling the data. Getting the information, just understand the catch. Okay, so SQL is the most widely used non-procedural query language. See the words how I'm putting. So this is normally there for different tools with different servers everywhere. Okay, so what I'm using? I am using the non-procedural language. Okay, we don't know where the files. We don't have any information, but still we are able to retrieve the data and we are able to work it out. And SQL is the most widely used tool in that. Okay. Structured query language. So like that it is defined. Structured query language. So a proper structure is there, like coming from the tables, coming from the definition, proper things. Everywhere the tables will have a proper structure. So the structured, then the query, like okay, like we have seen the how the things are defined, how the tables are defined, how I should be able to call it through different commands. So that's a part of query. Every year, every command is or script is termed as query. So structured query language. This is a proper structure for your script, proper structure for the tables, and like that you are working it out for through your queries. You are from your queries you are able to access the data and then call the values to analyze. Okay, like that it is there. Let us discuss it further. Okay, so SQL is the most widely used non-procedural language. We don't have any information how our data is stored, where our data is stored, but still we are able to read the data and work it out. Okay, so see this table here, see this example. This I'm using few keywords. Select from here. Okay, I'm using three keywords here. Select, from, and where. These are the three important keywords which the SQL uses or you can use to as select means I'm calling the specific attribute. Specific attribute. So whatever is there, this is the customer name attribute in the customer table. Okay. This is an attribute. Specific characteristic feature of the table customer. Okay. Then from customer. Customer is the name of the table. This is the okay. See the part. This is the name of the table. Okay, this is the name of the table. Customer. So customer, and then the part comes is this is the specific part through which I am comparing. See the part. I am checking customer name. Okay, customer ID. I want to select customer ID, customer name from the table customer, from customer table where this thing is correct. This part the filter is matching. This filter should match as per the question. This is the question. The customer ID is 192.83.7465. Okay, it should exactly match somewhere within the table. So show me the customer name from the table customer where account this customer ID is this given number. See the part how we are discussing. Show me the customer name from the table customer where the customer ID is this. Are you understanding? So that is the important aspect or important part of this SQL. Just by these commands, I'm able to retrieve even the billions of records, do the specific filtering and get the required customer name where the customer ID is 192.83.7465. Okay. Now suppose see the second question. Find the balances of all the accounts held by the customer with customer ID. Now I need to get the balance of all the accounts. Okay, so see, so simple it is. Select account balance, account table with the balance part. Okay, allow account balance from depositor and account. See the part, I am checking two tables here. After from depositor, comma account. Okay, see I am using here this one and this one used by a comma. Just by using a comma, I'm able to retrieve data from two tables. So that's the beauty here. I can call multiple tables all at same time, search particular part and get the required results where all these search conditions are satisfied. That is the beauty of all this. Okay, which is not feasible in some other programming language so simply. Okay. Now see the customer ID is the same as we discussed earlier, and depositor account number is the account number. See the next keyword and. So how many keywords we have seen? We have seen the and. Okay, we saw all this. So four keywords we have seen now in this part, in this slide. Okay, what are those? Select, from, where, and. Select is for like selecting certain attribute, certain important characteristic feature, defining the core element of a table. Okay. Then from is to get the data, get certain data. We need certain tables, so need to put the table name. Okay. So from is the name of the table. Don't worry about the extensions here. Only put the table names. That's enough. Moreover, if you want to put multiple tables, suppose three tables I want to put, so you need to put A, comma, again A, comma B, comma C, everything. The comma is the delimiter here. See, this is the delimiter here. Okay, the comma is the delimiter, and it will working out like it is able to get data from depositor and account both at the same time. Then where is the search condition? Okay, what is the filter? So here the filter is the customer ID and the account number. So that's the advantage. Okay. So like that things work out here. Let us discuss it further. Okay. So as a database administrator, what they do? Database administrator basically check out all the data, all the tables, all the schematic, everything is correct, or how the schema is defined, so that the data loss does not occur anywhere. That's the most important aspect. No data should be lost anywhere. Further after, see how the data is stored, or how are you able to retrieve the data in the fastest possible way, so that the processing time gets decreased. Okay, this is a processivity time index being calculated always, and the SQL keep on optimizing. SQL keep on optimizing then and it keep on monitoring its progress in the response to different changes. See, the tables are always dynamic. Different users have different parts, different permissions, they keep on changing the tables. Maybe multiple tables all at same time. So SQL keep a track of it. Even if something wrong happens, the SQL is able to understand which one is correct. We will be discussing all these aspects in the security concerns. Okay, so like that the architecture is there for the SQL. Normally, the user application is there, see, and the database system. Okay, this is a two-tier architecture where, like, I'm a user, I'm using an application, and through this application, I'm able to retrieve the data from the database system. Just like the Gmail, I'm opening Gmail from the Chrome using the Chrome. So Chrome is my application. I'm the reader user. Okay. In the case of SQL, I'm the reader or the editor. If I'm having the viewing permission, I'm the reader. If I'm having the editing permission, I'm the editor. Okay, or the administrator. But like that it works. And the database system, we always are connected through database system. So here ODBC or the JDBC parts are there. It works out. They are the core background shell. In the three-tier architecture, what happens? Like I am connected through an application client. Okay, so I'm just an application client to an application server. Okay, So my application client is just a node to retrieve the data from an application server, which is itself connected to like having a background of database system. So the application server has the database, and like I'm retrieving, as a user, I'm retrieving the data using the application client tool. So both application client and application server are just the different tools. Through this, the systems are kept much more secure. Okay. So normally web-based applications and different applications are worked out using three-tier. Okay, because it is much more secured. All right. So in this session, we have studied different commands. Okay, like select, from, where, and. Okay, so keep on understanding the things, these keystrokes further. Okay, so that we can have a good workout in this complete course. All the best to you.